Today, quite extensive. What are we going to talk today and why is it relevant? I think so far, judging by the projects that I see, judging by the interviews that I regularly do, we regularly face two problems or two sides of one problem. Where very often solutions are quite complex, excessively complex on the one hand, but on the other hand, they are excessively simple. Others, there are hybrids. Again, hybrids either underdeveloped or excessively complex. There's a link in my presentation to a document that can be used as a checklist for your automation, AQA automation, to check your automation, that it's fine, that the project is not falling apart. And you can also use this checklist for automation audit. So this problem is quite relevant, and I hope the presentation will be useful. Let's start with the terminology. Judging by interviews, we are mixing up layers and modules. And it's very important to properly use this terminology in your project. So a couple of words about these terms. Module is a deployment unit, and module consists of one or more layers. Layer is not a deployment unit, and each layer operates with one or two modules. So roughly speaking, we have a layered pie. If we have a complex solution, it will be a large pie. If it's a simple solution, then it will be a millefeuille dessert. And this dessert can be bought separately, given separately, and each layer of our dessert cannot be given to someone or bought. It would sound strange if we come to a store and say, please give me layer number 10 of this millefeuille dessert. This is, in a nutshell, about the terminology. The second problem we face with is the mix-up between the framework and the library. Again, to put it simple, library is a set of essences linked to each other, a number of classes that we use in our application. But this set of classes does not put any limitations on us about how are we going to use these classes. Framework is dictating on the one hand. So it's the set of entities. For example, there's a template method, a kind of family of algorithms, each of them 10 steps. Some of these steps are implemented, they are standard for all algorithms. Other steps are either virtual functions or any other entities that would be different for different families of algorithms. So this is the framework. So the framework actually sets out how we use our entities. Now we understand what is layer, what is framework, what is library. And now we need to identify the relations between the layers. If we speak about dependency inversion or inversion of control, the layers have the following relations with each other. The top layer knows about the existence of the below layers and communicates with it. But it can go down only one level. It cannot go several layers down. The below layer does not know anything about the above layer and cannot communicate to the above layer. And now we get down to our checklist. So these are the questions that we need to ask in any automation solution. Before that, we need to use the same terminology. For example, we have a number of layers. The top layer is the test layer, and this layer should comply with the 3A rule. So, what is it? The rule says that each test has 3 phases: arrange, act, and assert. Arrange means this is the phase where we do all the preparations. Then act, it's one and only one logical action from the viewpoint of business that we check. Of course, there might be several physical steps that we do, but in 99% of cases, we do only one action during testing. And there's assert. It's a logical assert. Well, physically, it might consist of a number of checks. But logically, from the business viewpoint, it is always one assert. In auto tests, there might be exceptions, but in 99% of cases.
So, if we talk about the automation of UI, we have to separate out 3 layers. That is very important. This is the layer of business actions, low-level actions, and page object layer. It doesn't matter whether we have very simple, straight solution based on static classes or a very complex one where the layer of business actions will be represented by REST service. In all of these cases, we have to formulate 3 layers: the areas of responsibilities, their boundaries, and we shouldn't mix all these concepts. Very trivial example. For example, we have a business action login, so we have to enter the system, and it will consist of different sets of low-level actions because our application evolves. For example, let's start with a classic login when we need to enter login, enter password. Then we will need two-phase authentication, and we will enter a code sent by SMS. Then, for example, we want to add CAPTCHA, then we'll have a secure app, and we need to use a physical token and use a generated key that will be changing every 30 seconds, and also token IP for additional security. So possibly that with time we'll need a physical hardware token, like a memory stick, which we put into our system. In any case, from the point of view of business, we will have same action, which is to log in. In the ideal world, our tests should not change at all or change insignificantly. At the level of test, we operate on the business actions, and business actions consist of one or more low-level actions, and they will evolve with time, becoming more complex or more simple. We have to remember about simplification as well. And also we have a page object, which in the majority of cases is a logical, not physical page. And in many cases, these low-level actions are associated with this or that page object. Regardless of the way of implementation, all these 3 layers have to be present.
For the backend, we will have only 2 layers: business actions and low-level actions. I hope you heard or saw that in a classical UI way you might use page objects for AQA testing. But there is no such layer. This layer does not exist. Maybe for you it would be convenient to group these actions in the low-level action layer. Let's call it page object, but it sounds strange and illogical because we speak about backend in page terms. Let it be a group, of course. Okay, it doesn't matter, but it matters that there should be two layers. Well, as far as modules are concerned, speaking about UI, there should be the following modules. UI engine. This is something that is used to identify UI element for web, for mobile, for desktop. Quite often we'll need a ready-made UI engine wrapper because maybe UIs are low level for various kind of solutions, not only AQA automation, but also for other purposes like scripting, small-scale automation, etc. We need to bear in mind that such module should exist. And also we need some specific UI helpers that are specific for our project or domain. But we understand, since we have a fully fledged engine and a fully fledged wrapper, these helpers might be very small, lightweight. For the majority of domains, it might start with a static class, a dozen of methods. It might be developed into a different web space with 3-4 entities, but still. And smart singleton, you can see it here.
And this basically entities in 95% of cases are orthogonal to other entities within the project. So it's orthogonal to the project itself. So when we start the project, we demonstrate this feature and produce a simple singleton. So if we understand that we need not just one entity, but half of the entity will have just one place, we will put enter, stating that it's singleton with 10 instances or one instance per nucleus. And the number of instances will be same as the number of flows, but it will be one and the same place. It will not influence our tests and the project as a whole. Also, if we are not satisfied with the standard test launch methods and we want to use something else, we'll have just one place where we'll have to do this synchronization. We add guard to this smart singleton and it works fine. So in this way we avoid a number of issues. For example, when we just don't think about that, when we use Selenium driver, we create a driver, we release it, we transfer it from method to method, from one to another, and then we think, why do we need to do that if we have one driver, only one, and it contains an algorithm of test scenario actually. So then do we need to transfer entity from one place to the other? By that we make the code bulky, and if we will need to make parallelism of this rating, then we will not understand how we transfer the entity, where it's kind of locked, stored. So if we talk about backend, the number of layers is less, but the number of standard modules is more. What are these modules? This is an HTTP engine, because we need to make request, response, and without an HTTP engine, we'll not be able to do that. This is a standard task, and there are very nice wrappers about these engines, which add give us additional synthetic sugar. It's rest assured for Java, which has laconic syntax. It supports fluent interface for libraries, which is good for libraries. For UI automatization, it's an anti-pattern in 99% of cases. And also it supports PDD notation, which is easily understood by many users, and they can either use it or not. So we have an engine, we have a wrapper, and also we need a ready-made ITTB builder parser, because we will make requests, responses, parameters, cookies, and other entities. And in many cases, these libraries are implemented using Fluent interface and being builders by themselves. So, I mean, we build them out of several steps, of several stages, some entity. So, also to test IPI, even if we start with something simple, we have to, from the very start, we have to understand that without mock engine or mock model, we won't be able to work. Because this is the main point, I mean, the isolation of an entity and this incremental increase of connections, modules, which we are going to test. And for sure, at the last stage, we get a module specific for our domain, which in many cases will be very lightweighted. So that's why if you are doing some audit or if you launch a project, so don't start with writing something on your own, inventing bicycle for the 125th time. That's not needed. And general purpose modules, we will of course have a general purpose helper. Normally there are only several methods. It shouldn't be lightweighted. Then it's a logger, tracer. Then it's a test runner. Without it, we won't be able to run our tests. Also, this is a reporting engine, some reporting engine. And it can be, not necessarily, but can be customized integration module. These are so-called smart singletons, orthogonal entities. What do I mean by our private customized integration module? So we always use many tools for management. As a minimum, we have a bug tracking system, task tracking system, and, for example, a Confluence. And we would really like not only to create a good reporting with auto tests, but also integration with all these systems. For example, this report can be automatically deployed in our Confluence. Although we have a traceability matrix, and after each run, we would like to update the traceability matrix or not to update, so that we have some tick that we put on the box when doing the test run. And if we do debugging at our machine, so traces have to take the matrix of the last run without updating it. But if it's full-scale test run in the environment, then we have the classic traceability matrix, which shows which was done manually, which was done by auto tests, and what was not tested at all. And also we have a traceability matrix, and this is its current cross-section, showing what happened during the last test run. And for example, we want to update it automatically. Also, we have other systems, and probably we want to update some flags in them. For example, we might have a test management system which needs updating. What is automatic, which was done in manual mode, and the results of the last test run. But if the already made modules for integration are not good for us, then we have to ask a question. Do we need ones? And normally we do. We either find them now, or maybe we put it in the plan that we find them later when we have such a priority, or we can write small integration ourselves. If we talk about Atlassian family, it's a very simple laconic API which we can use, and plan some man hours for this integration, but we need integration for sure. Also, if in our solution we don't use project or design patterns, then we need to think about that. It's not necessarily that we have a mistake, but we have to think of that, because if our solution includes some additional patterns which are widely used, then we have to think about that. Do we need them? Or maybe we make it too complex without any need. I mean, the architect, designer, he read some new book on architecture and decided to implement all that at once. And if we talk about automation, then we will have the next AQA patterns. All of them are connected with UI. As you see, we need page element. That doesn't mean that we here we don't talk about the button or about something lightweighted, but I mean if we have tables or some other complex controls, then we have to use a page element. Next thing is that we have to use a page object, and we have to ask ourselves whether it's a logical or physical page. In most cases it will be a logical one, and also whether it's static or dynamic. In most cases it is dynamic, but honestly it's also too complex, and we can stick to just a static one. Regarding the actions, we can have low-level and business-oriented, and if we decided to use domain-specific language, then we have to seriously think about that. Don't decide too quickly on that. So if we want to use domain-specific language, then we need to have domain, which is quite specific, quite complex for understanding. If you don't have such, then you shouldn't use DSL. It will be overcomplicating the matter. And also DSLs, we have two types. This is an internal one, and in automation it's normally implemented via fluent interface or flow pattern. If it's external, then it can be, for example, BDD, so it's an external DSL, and general purpose patterns. Normally in automation we use singleton. Well, actually it's an anti-pattern globally, but in automation the density of singleton use is many times more than in development, because we have a lot of orthogonal entities, and that's normal. This is a feature of testing automation. We will use the abstract factory and factory method for complex cases to implement inversion of control and dependency inversion, and also we will encapsulate creation of a number of entities, which is a builder, which is what the builder is for. Also, rarely, but still, we use the composite. If we have a composite entity or object, we need an iterator to go through all the sections of this composite object, and also we need a visitor to, while visiting each node of this object, we should be able to do something with this node, with its contents. And also we need a decorator. So actually if you have some other patterns which are not in this list, it's not a mistake, but you just have to think whether you need to use that, because maybe you are overcomplicating this process. And there are some additional questions which you have to answer when launching, when auditing, or when synchronizing your project. These are the questions of decomposition and encapsulation. We have to decompose everything we can. We have to break our task down into smaller subtasks, both horizontally and vertically, so that we use our cognitive abilities better, because our abilities are limited. We have to understand that. And also we have to encapsulate the entities, and there is constant or permanent conflict in that. We either encapsulate either potential diversity or complexity, and sometimes encapsulating the variability, we increase the complexity. So there is no rule of the levers when you win in all cases or at all stages. So if we prevent something, if we are protected against something, then we pay for that by losing something. And also we have to remember about the basic engineering solutions, like don't repeat yourself and single source of truth. And all of you heard about refactoring, but in the design architecture, the most important types of refactoring are from conditional to polymorphism, and the other one from polymorphism to conditional. Rephrasing that, we have two refactoring types. When we have to proceed from procedural style to interface and different versions of the interface, like factory, which creates for us what we need, and if we go the opposite way. And also, this is a classical question in job interview, because a person has to explain what is polymorphism, heritage, integration, etc. But then you ask him, in our automation, we have 2 or 3 places just for 2 platforms. For example, we make auto tests for a mobile app, we have Android iOS, and we have 2 or 3 sports. Is it enough for us to write if, or do we have to make an interface common for the platforms, or should we create a factory which would create 1 or 2 of these? And this person interview says, maybe it's too overcomplicated. 2 if is too much, and also number of switches, whether 2 are enough, or maybe only 3 is enough and 4 is overcomplication. So we just have to think about that, because our software is created by us and it will evolve, and auto tests that we use have to evolve. So normally you have to start with a standard solution. If you use just 1 if, but then you see that number of platforms grow and there are some special cases emerging, so then you understand that we have to proceed with the oriented solution. Then we open the book about refactoring by Paul and read about polymorphism, and there you see step-by-step procedure how to actually do that. Then after 1 or 2 years it evolves even more, and you understand that some platforms were not really used a lot, and you decided to support only the 3 top ones, so that's when it's hard time to go back. And just following the algorithm, we return back. And also, when we use our framework, we have like 3 modifications of our framework, and we have to remember about the minimum valuable product concept. And here we see 2 options, how we can do that. The final result is the same. We produce a car, let's say, or we get 1000 auto tests which work perfectly stable. However, in the first case, before we finish even, we do not get any intermediate value. And in the second case, at the first step, at the end of the first iteration, we create an MVP. We have a pipeline, we have a pre-commit event, and within this pre-commit event we launch our auto tests, we receive a full-scale report which is integrated with our systems. Okay, we have just 3 smoke tests, but they already wield some use. maybe a very small one, but still. So that's what we have to remember when we work on our framework or modify it. So what shall we do next? Here you see the list of very useful videos. I think they are useful, and all of them are somehow connected with the architecture, automation of testing, front end or back end, or some other general issues. And one of the reports is dedicated to MVP in automation. What should be included in this concept, kind of, which is a must to include in it. And also you can read this one, and maybe you can add something from that to your project. Maybe you will add something or miss something, skip something. So, but still it's a good start for you. I think you will really use it. Thank you, and ask your questions. I think we have at least 5 minutes for the questions. Thank you very much. We have the first question coming. Hello. Thank you for your presentation. You said that using the WebDriver through page object or page element, and it's better to use singletons. But how to do a parallel launch? Well, in any case, our driver contains current context of the page. So if we need to do it in parallel, then we'll have one driver per flow or per stream. We don't need to use several contexts or several drivers in one flow. And if we use one driver per flow, then it's better to create a singleton with a pool of drivers where there will be a flow safe map, which after flow ID will produce a driver which corresponds to some flows. But
well, in the majority of cases, we could speak about parallel launch of auto tests. In the majority of cases, we are going to use other tools at the level of assembly, etc. So, in some very complex cases, we will clearly see that for our tasks, all these standard solutions are not relevant. So that's why then we start to parallel it at the level of flows or streams. Like Selenite, someone likes it, someone dislikes, but it is one of the largest and most popular libraries. And it employs the same approach. It contains a pool of drivers as a set of orthogonal entities. And I would pay attention to the benefit, to the value. If there isn't a value, then yes, why not? Any more questions? Great, thank you, Anton. Thank you as well. I have no doubts whom the t-shirt goes for the best question. So you will definitely receive this t-shirt. On the slide you can see my contact details. Should you have any questions, please write to me.